Our bodies are incredible machines, made up of trillions of cells working together in harmony. Each cell plays a specific role, growing, dividing, and dying in a highly controlled manner. But sometimes, this delicate balance is disrupted, and a sinister force emerges: cancer. Cancer is essentially a disease of uncontrolled cell growth. Imagine an army of rogue cells multiplying uncontrollably, defying the rules that govern normal cell behavior. Cancer cells are like seeds sown in fertile ground, but instead of nourishing the body, they drain its resources and wreak havoc. They are our own cells gone awry, transformed by genetic mutations that turn them against us. These mutations can be caused by a variety of factors, including exposure to carcinogens like tobacco smoke, ultraviolet radiation, and certain viruses. Imagine a bustling city with well-defined roads and traffic signals. In a healthy body, cells follow these rules, knowing when to grow, when to stop, and when to die. But cancer cells are like reckless drivers, ignoring the signals, speeding through stop signs and causing chaos in the city. They multiply without restraint, forming tumors that invade surrounding tissues and organs. The fight against cancer is a fight for our body's very essence, a battle against a formidable foe that resides within. But it's a fight we are increasingly equipped to wage, armed with knowledge, determination, and cutting-edge science. The transformation of a normal cell into a cancerous one is a complex, multi-step process. It begins with a single cell acquiring a mutation in its DNA, the blueprint that governs all cellular functions. These mutations can be inherited from our parents or acquired throughout life due to environmental exposures or random errors during cell division. Imagine a delicate tapestry, intricately woven with threads representing our DNA. Each thread holds crucial information that dictates how our cells function. Now, picture a few threads becoming frayed or broken, disrupting the intricate pattern. This is akin to DNA mutations that can disrupt the normal functioning of our cells. As these mutations accumulate, they can disrupt the delicate balance of cell growth and death. Genes that normally promote cell growth can become overactive, like an accelerator stuck in the on position. Conversely, genes that normally suppress tumor formation can be inactivated, like faulty brakes in a speeding car. This interplay of genetic alterations creates an environment where cells become immortal, evading the normal checks and balances that control their growth. They begin to proliferate uncontrollably, forming a mass of abnormal cells known as a tumor. While the formation of a primary tumor is a significant event, the real danger lies in cancer's ability to spread, a process known as metastasis. Cancer cells can break away from the primary tumor and travel through the bloodstream or lymphatic system to distant sites in the body. Imagine a dandelion releasing its seeds into the wind, each seed carrying the potential to take root and grow in a new location. This is akin to how cancer cells can spread throughout the body. Metastasis is a complex cascade of events that involves multiple steps. First, cancer cells must acquire the ability to invade surrounding tissues, breaking through the normal barriers that keep cells in their place. This is like a group of prisoners digging a tunnel to escape confinement. Once they've breached these barriers, cancer cells can enter the bloodstream or lymphatic system, using these vessels as highways to travel to distant organs. Upon reaching a new site, cancer cells must then establish a foothold, adapting to their new environment and forming new tumors. This process, known as colonization, is the final and often most challenging step in metastasis. Metastasis is a major reason why cancer is so difficult to treat. Once cancer cells have spread beyond the primary tumor, it becomes much more challenging to eradicate them completely. The impact of cancer on the body is profound and far-reaching, affecting not just our physical health, but also our emotional and mental well-being. Cancer cells are like relentless invaders, their presence disrupting the delicate harmony of our internal systems. As tumors grow, they can compress or invade nearby organs and tissues, interfering with their normal function. For example, a lung tumor can press on the airways, making it difficult to breathe. A brain tumor can disrupt nerve signals, leading to seizures or paralysis. The location and type of cancer dictate the specific symptoms a person experiences. Beyond these localized effects, cancer can also have systemic consequences. Cancer cells release substances that can disrupt the body's normal metabolism, leading to fatigue, weight loss, and muscle wasting. They can also suppress the immune system, making the body more vulnerable to infections. Cancer's impact extends far beyond the physical realm. The diagnosis of cancer can be emotionally devastating, evoking feelings of fear, anxiety, and uncertainty. The treatments themselves, while life-saving, can also take a toll on the body, leading to side effects that can impact quality of life. Section 5. Hope on the horizon. Advancements in treatment. Despite the challenges posed by cancer, there is much reason for hope. The landscape of cancer treatment is rapidly evolving, with groundbreaking discoveries and innovative therapies emerging at an unprecedented pace. Scientists are constantly unraveling the complexities of cancer, identifying new targets for treatment, and developing more precise and effective therapies. One of the most significant advancements in recent years has been the development of immunotherapy, a revolutionary approach that harnesses the power of the body's own immune system to fight cancer. Immunotherapy works by boosting the immune system's ability to recognize and destroy cancer cells. It's like giving the body's natural defenses a much-needed boost, empowering them to fight the cancer more effectively. Another promising area of research is targeted therapy, which involves using drugs that specifically target the molecular abnormalities that drive cancer growth. Unlike traditional chemotherapy, which attacks all rapidly dividing cells, targeted therapies are designed to selectively kill cancer cells while sparing healthy ones. Imagine a guided missile that can zero in on and destroy a specific target, minimizing collateral damage. That's the promise of targeted therapy. Section 6. Immunotherapy. Harnessing the body's defenses. Immunotherapy has emerged as a game-changer in the fight against cancer, offering new hope for patients with even the most advanced forms of the disease. This revolutionary approach works by enlisting the body's own immune system to recognize and destroy cancer cells. Our immune system is a complex network of cells and molecules that constantly patrol the body, searching for and eliminating foreign invaders like bacteria, viruses, and even abnormal cells like cancer cells. However, cancer cells are cunning adversaries, often evading detection by the immune system or suppressing its activity. Immunotherapy aims to overcome these obstacles by either stimulating the immune system to work harder or by providing it with the tools it needs to recognize and attack cancer cells more effectively. There are different types of immunotherapy, each working through different mechanisms. Immune checkpoint inhibitors. These drugs release the brakes on the immune system, allowing it to mount a more potent attack against cancer cells. CAR T-cell therapy. This personalized approach involves genetically modifying a patient's own immune cells, T cells, to recognize and kill cancer cells. Cancer vaccines. These vaccines are designed to stimulate the immune system to recognize specific proteins found on cancer cells. Immunotherapy has shown remarkable success in treating a wide range of cancers, including melanoma, lung cancer, and leukemia. While it's not a cure-all, it offers a powerful new weapon in the fight against cancer. Section 7. Targeted therapy. Precision strikes against cancer. Targeted therapy represents a paradigm shift in cancer treatment, moving away from the one-size-fits-all approach of traditional chemotherapy towards more precise and personalized treatments. This approach involves using drugs that specifically target the molecular abnormalities that drive cancer growth. Imagine a lock and key. Targeted therapies are like keys designed to fit specific locks. In this case, the molecular targets that fuel cancer cell growth and survival. By binding to these targets, the drugs can block the signals that tell cancer cells to grow and divide, effectively putting the brakes on cancer progression. There are different types of targeted therapies, each designed to interfere with specific molecules involved in cancer development. Tyrosine kinase inhibitors. These drugs block the action of enzymes called tyrosine kinases, which play a key role in cell signaling and growth. Monoclonal antibodies. These laboratory-produced antibodies are designed to recognize and bind to specific proteins found on cancer cells, marking them for destruction by the immune system. Angiogenesis inhibitors. These drugs block the formation of new blood vessels that tumors need to grow and spread. Targeted therapy is often used in combination with other cancer treatments, such as chemotherapy or immunotherapy, to enhance their effectiveness. While it's not without its limitations, targeted therapy represents a major advance in cancer treatment. Section 8. The future of cancer treatment. A glimpse ahead. The future of cancer treatment is bright, fueled by ongoing research and innovation that promises to transform the way we diagnose, treat, and prevent this devastating disease. Scientists are exploring a wide range of promising avenues, including artificial intelligence and machine learning. AI is poised to revolutionize cancer care, from improving early detection and diagnosis to personalizing treatment plans and predicting treatment response. Liquid biopsies. These tests analyze blood or other bodily fluids for the presence of cancer cells or DNA, offering a less invasive and more convenient way to monitor cancer progression and treatment response. Cancer nanotechnology. This rapidly evolving field involves using nanoparticles to deliver drugs directly to cancer cells, increasing their effectiveness while minimizing side effects. Cancer vaccines. Researchers are working on developing new and improved cancer vaccines that can train the immune system to recognize and destroy a wider range of cancer cells. The ultimate goal of cancer research is to find a cure, but in the meantime, scientists are striving to transform cancer from a deadly disease into a chronic, manageable condition, much like heart disease or diabetes. Section 9. A call to action: research, awareness, and support. The fight against cancer is a collective effort that requires the participation of scientists, clinicians, patients, advocates, and the general public. We all have a role to play in advancing cancer research, raising awareness, and supporting those affected by this disease. Supporting cancer research is crucial for developing new and innovative treatments and ultimately finding a cure. By investing in research, we are investing in a future free from the burden of cancer. Raising awareness about cancer is equally important. By educating ourselves and others about cancer prevention, early detection, and treatment options, we can empower individuals to make informed decisions about their health. Finally, supporting those affected by cancer is essential. Cancer patients and their families often face significant physical, emotional, and financial challenges. Providing emotional support, practical assistance, and access to resources can make a world of difference in their lives. The fight against cancer is far from over, but with continued research, unwavering determination, and unwavering support, we can make a difference.